Let's calculate the maximum shear stress in this section. And we know that the maximum shear stress occurs at the centroid. So by the shear formula, we have tau at the centroid is the shear force by Q on the second moment of area by the thickness of the shear plane. And Q is y bar dash by A dash. So here we take our cut at the centroid of the web, thereby exposing the shear plane, and we have a shear stress on this shear plane. And therefore the area A dash is this area over here that we take above the centroid of the section. So given that this is a composite area, we can break it up in two, and we can calculate y bar dash for the web by A dash of the web plus y bar dash of the flange by A dash of the flange. So this is A dash F, and this is A dash for the web. And we can measure the y bar dash values from the centroid of the section to the centroid of the web and flange. So y bar dash web is simply the height of this upper half of the web divided by 2. Multiply by the area of that web. So that would be 100 by 15 millimeters. And plus y bar dash of the flange, which is 100 millimeters plus 10 millimeters to the centroid of that flange. And then multiply by the area of the flange, which is 300 by 20 millimeters. So that gives 735,000. And the units are millimeters by millimeter squared. So that will be millimeter cubed. Now the shear force is given in the problem, which is 80 kilonewtons, which we convert to newtons. The second moment of area has been calculated for this section, which you can verify yourself. And the thickness of the shear plane is the thickness of the web. And then if you substitute for Q and calculate this out, you'd get 25.2 megapascals. Please subscribe, like and comment to help me reach more students.